Right now, I'm going to go into the early history of the development of guidelines for seismic retrofit of crippled walls. And we had to go back to Los Angeles because that's where it all started. There was an engineer named Jim Russell, and he was the chair of a committee of various other engineers, including John Karyotis that you see here and Ben Schmidt. And so anyway, they had a committee, and that was based on a request by the city of Los Angeles to put together some kind of guideline that they could do something to retrofit homes. And actually, as far as I know, this was done before the Northridge earthquake. And the reason I say that is because I flew down to Northridge right after the earthquake. The person I met at the city of Los Angeles, who was part of a department that specialized in earthquake hazard mitigation after the earthquake, he handed me this brochure. And it was pretty funky. It just 8.5 by 11 sheets, had a cardboard binding. And he said, well, this is what we use. And that's all that existed, was just that one little brochure. Now, that brochure eventually evolved into some other guidelines, and I'm going to show you what it did. So it went from that brochure, then it went into the Uniform Code for Building Conservation. So that wasn't adopted until, I think, July of 1999. Which is approximately 5 years after Northridge. So it took quite a while for that evolution to take place. But I remember when the UCBC did come out, I compared it to the document I had, and they were virtually the same thing. So that was the very beginning of the seismic retrofit guidelines in the state of California. So with that, the Department of Building and Safety, they came up with a standard plan number 1, and they used a lot of the construction details there to put it together, but that is what they use. If you go to the city of Los Angeles, you say you want to retrofit your house, they hand you this sheet, very much like a standard plan A. It's a plan set. It's only one page, and they just hand you that, and it's pretty much all there. And it has roots in the brochure that I told you was given to me. Now, in its entirety, you will still find it in the 2019 California Existing Building Code, Appendix Chapter A3. So you'll still find it there. So anyway, the evolution of that little brochure that was given to me went into the California Existing Building Code. It went into the plan set for the city of Los Angeles, which is still used. And then from there, it went into the city of Seattle and the city of Portland. Both have their own set of guideline, and they are also based on that brochure that was given to me many, many years ago. So that is the early history of the guidelines in the state of California. Once the information in that brochure finally migrated into the building departments in Seattle and in Portland, that was pretty much it as of right now. However, in Northern California, things were a little bit different. Jim Russell had moved up to Walnut Creek, and I had gone to see him, and I found his name because at the beginning of that brochure I was telling you about, his name was listed as the chair. So I went and saw him because I had some construction details that I wanted him to look at. At that point, I was pretty much 100% self-taught. There was a structural engineer I used to consult, and the way it would work is I'd crawl under a house and go, okay, this is a weird situation. I have no idea what to do here. And then, that engineer and I would come up with a solution. Then I would create a detail for my crew, and then every time they saw such, a certain configuration, a framing configuration, they would know exactly what to do. So I had created, 30, 40, 50 details. It just seemed like there was always something new coming up. And so when I went to see Jim, and I said, here, would you please look these details over? And he looked them over, and he said, yeah, it looks like your engineering is pretty good. So I was okay with that. And then I told him that I crawl under a lot of houses, and I've been seeing a lot of very, very poor quality work. And he just took that in stride, and we said goodbye, and that was kind of the end of that. And so then later on, the California Earthquake Authority, under a program called the SAFER program, what they did is they hired an engineer to come out to people's houses, just tell them, what sort of structural weaknesses they might have. And then if the owners wanted to, they would hire that engineering firm directly to design their retrofit. And so there were a lot of, I got a lot of phone calls to, implement these retrofit designs. And so I went to a few of them, and in my opinion, they were just terrible. They made absolutely no sense from an engineering point of view. So let me show you some of the things that I saw. So like this one right here, this was one that was there. And here, there's a post right here, and then here's the pier block, and then this is a girder. That's the exact same thing that you would see over here. Here's a post, a block, and then here's a girder. So what they're doing here is they're putting this big steel strap right here. They're putting this, they're bolting the base of that post, and then they're coming up here and they're putting in this piece of hardware right there. And I went and looked at all this stuff in the Simpson catalog, and basically it said right here it's non-load rated. So basically it's not resisting earthquakes. There's no reason to have it. The city of Los Angeles, when they did their work, they didn't identify those posts at all as being important. So this is a structural engineer who came up with this design. So then I also showed him something like this, where there's a shear wall, and then it had these blocks behind it in a very weird way. And I showed him that there was some shear walls designs that I saw where there was like a block every 2 feet behind the plywood that you're supposed to be nailed to. And the American Plywood Association had never tested that. There was no confirmation anywhere that that did any good. So that was also unnecessary expense and a lack of engineering expertise from my point of view. And then I showed him something else that is a very similar problem. And so remember, here we have this pier block and we have this post. Well, this one engineer's solution is to do this elaborate, I don't even know what to call it. So he has this huge glob of concrete right here, then he has a stem wall, then he has a steel connector right here, and then he comes up and he puts one of these brackets on each side, then he puts a steel strap across the whole thing. And in the end, it says, the building code says the columns shall be restrained to prevent lateral displacement at the bottom, and that pretty much means you need a nail. So I pointed out all this stuff to him, and he said, "You know what, Howard? I can see your point. There is definitely a big problem here." Now, fortunately, Jim was a plan checker for building departments all over the Bay Area. He contacted all of them, and he said, "Hey, you know what? We need to put some kind of guideline together because there's obviously some misunderstandings." And so that's when the Standard Plan A committee was formed, and there were like 13 building departments. There was a lot of people. Previously, I had talked about a brochure that the city of Los Angeles had given me. Actually, it was more like a pamphlet. It was, it had a lot of details, had a lot of text, and Jim Russell had been the chair of the committee that put that together. And so there I am in his living room, and I'm also pointing out some things about that pamphlet that I thought he should be aware of. And one of them is that this detail right here that has the flat plate, which we also see in P1100, it wants you to cut this trapezoidal shim, which really takes a whole lot of time, and then put in this beveled washer. Well, create a trapezoidal shim, it takes a lot of work. You got to take a 2x4 off your truck, then you got to cut it at an angle, and then they want to be, it's supposed to be flush right up against the sill and flush up against the where the plate's going to go. It's a ton of work. And then the other thing is, where is someone going to find a beveled washer? They don't sell them. At least I've never seen one. And if you really look at it, it depends on the angle of the concrete, how much of an angle, how much of a bevel should that washer have. So that was really problematic, especially in the fact that at that time, a new piece of hardware called the UFP10, which you can see right here, that had been invented. So to keep a standard out there that has archaic hardware like that really didn't make a whole lot of sense, and it didn't make any sense to him either. The other thing where you see right here, this has these blocks that are nailed to the mud sill, and there are actually much better ways to do that, and I pointed out that there are some much better ways, because the problem with the blocks is they do split. And so I pointed out there were some other things that he should probably want to look at. And I also mentioned that contractors need to respect these guides when they come out. So, for example, in this one right here, it says that here this is the rim joist. And then here you're supposed to put a new 2x rim joist installed to fit tightly between floor joists. Now, any contractor knows that a rim joist is what sits on the outside of and is perpendicular to the joist. It is not a block. So when he talks about putting a new rim joist in between two joists, he's really talking about a block. So what happens is contractors look at that and you go, well, this guy doesn't even know the difference between a rim joist and a block. And then they just want to discount the whole thing. So it has to be whatever standard is developed. It has to be something where they know, hey, this guy understands my profession. He understands the nomenclature that I use every day in order to look professional. So anyway, that was another reason in the end. He said, you know what, Howard, we just got to start all over. We're just going to, just ignore that. It just didn't work. It had its time, it had its place, but we just have to start all over. And again, that's when Standard Plan A developed. Now that Jim and I had decided what needed to be done, Jim was elected to be the chair of the committee. He was the most knowledgeable by far. And so he came to the first meeting and we discussed things. Jim had to do some calculations, which was going to be the engineering basis of the whole thing. And so when he was done with that, we met one more time. And that was the last I think I saw of Jim, because what happened is he had developed a cancer probably caused by his 2 tours in Vietnam, where I'm sure he was exposed to Agent Orange. But anyway, he decided he had to do other things with his life other than be on this committee. So then there was a building official who was appointed, and they had absolutely no understanding of earthquake engineering at all. So he was the chair of the committee, and so then we would meet once a month. And the funny thing is 1 month a certain group of people would come, then the following month a different group of people would come, and so what would happen is the first group would make a decision, then the second group would say no, they didn't make the right decision, and then the first group would come and go, yeah, well, I think we got it right, and then finally the chair would just say, well, you know what, I'm just going to make a decision myself. And he'd make a decision about the way certain things were going to be done in that standard. So that went on for quite a while. I was the only contractor there, and there were quite a few building officials and structural engineers who did other things, designed skyscrapers or just did other things, but certainly not wood frame retrofit. So finally, quite a few years went by. I can't remember, it's 2, maybe 3 of meeting, and people were just getting really sick of it. So they finally, before it was, in my opinion, finished, they decided to go ahead and adopt it. And actually, I didn't even know about it. It wasn't at a meeting, they just did it amongst themselves. And so they went ahead and adopted it. And everyone signed off on it, the Earthquake Engineering Research Institute, and actually all these organizations that had never even been there. They all signed off on it, and then it was adopted. And the really weird thing to me, I thought, was no one ever tried to use it. And I told them that what we had created was not going to work for the houses that I see. The houses that I see don't look like this little book where it's got a double top plate and the walls are all lined up perfectly and the floor framing looks like that and it doesn't have any pipes in the way. And this is kind of funny. I remember I was going through this, these thoughts, and I went to an existing buildings committee with SEONC in San Francisco. And I told one of the engineers there what the situation was. And he said, oh yeah, we call that the professor's house. So that's the one he puts up on the blackboard, everything's lined up and it's all perfect. And then he talks about some engineering principle using this house that actually doesn't exist in the real world. So I explained that to the people on the committee that, what we're working on here does not match the real world. And I was told that we would then start another committee, which would create something called Standard Plan B. That was at the very last meeting we were at. That was, I remember, at the Earthquake Research Institute in Oakland. That was our very last meeting. And I was told, hey, we're going to do a Plan Set B, and then that never happened. We never had another meeting, and that was the end of the creation of Standard Plan A. Not much happened in the seismic retrofit world after Standard Plan A. until the 2014 Napa earthquake. And let me show you what happened. So here was Jim Russell and the committee of which I was a member. And then we created Standard Plan A. And I'm putting the Association of Bay Area Governments here because they're the ones who really put everything together. We used to meet in their offices. All the building officials knew them, and they were good. They coordinated a whole lot. So I would give them a lot of credit. And then after the Napa earthquake, it went here, and they created this guideline, and I call that the Napa guideline. And it's very similar to Standard Plan A. And the way Standard Plan A was different than the UCBC, or that guideline that was given to me when I first went to Los Angeles. The way it was different is that Appendix Chapter A3 was based on percentage of wall line for the amount of plywood. So, for example, a two-story was 70% on each wall line. And it was also based on a part or on center. So for bolts, it was 4 feet on center. For shear transfer ties or framing anchors, it was 32 inches on center. So along the entire perimeter. So when I talked to Jim about this whole system, and I told him that, in my opinion, you were wasting a lot of hardware and bolts, because really, if you're on the long walls, you'll end up putting a whole lot more bolts than you will on the short walls, and you're only as strong as your weakest link. And he agreed with me. And so what happened was this new table, which is started Standard Plan A, it came about. And on this table, everything is equal on all sides. So, for example, let's take a look at the section that says for a 1,200 square foot heavy construction, we want plywood bracing on each wall line at 20 feet. And we need to have 9 half-inch bolts, and for L90s we have to have 17 of those. So that was the big difference between the two. One used a percentage of wall line, and then it did just equal spacing of bolts or equal spacing of the framing anchors, whereas Standard Plan A used this table. And this table then reincarnated into the Napa guideline. And now they're using a very similar table in the new FEMA P1100, which is being reviewed right now to see if it should be part of the building code.